Okay, today we are doing 7.2, which is angles of rotation and radian measure. So before we get into radian measure, we are going to jump around a little bit in these notes, and I actually want you guys to flip it over to the back side where we have this picture of the unit circle. So before we go into the details on the unit circle, I just want to make sure that you're aware of how degrees works. So right here, at this right here is the initial side of any angle that we're going to work with. And if we're in a circle, we know this is 0 degrees, but it's also 360 degrees because when you do one full rotation around the circle, that's 360 degrees. So then from there, if you only go halfway around the circle, so let's say you go all the way to here, that's just going to be 360 divided by 2 because that would be half the circle, so that's going to be 180. So this right here is 180, okay? 180 degrees. Now, what if you cut 180 degrees in half, so you only go to here? That would be 90 degrees, which I'm sure you're aware of. So this guy up top here is 90 degrees. All right, so what we have is here we have 0, then we go 90, then we go 180. And you can kind of see the pattern. You go, if you just look at the first or second digit, you have 9, 18. So I know I said 90 and 180, but just ignore the 0 at the end. So we go 9, 18. And you can see that this bottom one would be 270 degrees. And then so 9, 18, 27, and then we're going to end up with 36 right here. Okay. All right. So I'm going to erase those for a minute just so that we can focus on the next little bit if you don't know your measures of angles. So from here to here, you can see that's 30 degrees. And from here all the way up to here, this is what we said was 90 degrees. So what's in the middle? So what's in the middle of 0, which is right here, and 90? That would be 45 degrees. So right here we have a 45 degree angle. So we go, if we trace this, we go 30, 45, 60, 90. Okay, so now we're going to go into the next round. We can see we have 120. And then this right here is going to be 135 because this is in the middle. That's a bisecting angle. So 90 plus 45 is 135, plus another 45 is 180, and then plus another 45 will be 225. So this right here is 225 degrees. And then another 45 will get us to 270, and then we cut that in half again. If we add another 45, we're now looking at 315 degrees, and then we're going to end up back up at 360. We can do that same math for a 30-degree angle. So from here to here, because this right here is 90, if I cut it in to 3 equal pieces, and what I'm doing is I'm kind of ignoring this 45 right here because it's kind of in the way. So if this is 30 and this is another 30, so we have 30, then we get to 60, and then another 30 we get to 90, then another 30 gives me 120, and that's this guy right here. Again, we're ignoring that 45-degree angle so that we can see it cut in 3, and then that pattern just keeps continuing through. So you're just adding 30 each time to figure out what those other angles are. They're already written there, so that's why I'm not writing them in right now. We have 300, 330, and that gets us back to 360. It's simply a ratio situation, so you should be comfortable with that. So that was in radians. So now we are going to flip back to the front side and learn a little bit about angles So when we're doing angles, you are going to have your initial side, and your initial side always starts right here. Okay, so your initial side always starts at 0 degrees. Okay, and then you have two choices. You can either rotate up, which would be a positive angle. So this, again, if you go up, is a positive angle. So if I say positive 45 degrees, you are going to go up from 0, which is in the counterclockwise direction. And if I say a negative angle, you're going to go down. So if this was a negative angle, it's very similar to the positive angles. These just all become in the negative direction. Okay, so that's what that looks like. So again, positive direction if we go up from 0, and negative direction if we go down. So that's always your initial side, no matter what, is 0. And then the terminal side, don't let that big vocab word confuse you. Terminal side just means where the angle is graphed at. So right here, this one looks like it's at about 135. It's where the angle ends up, which is why it's called the terminal side. Okay, so there's two ways, maybe more, but two ways that we're going to learn in our class on how to measure angles. So the first way we talked about was measuring in degrees, but there is another way, and this is probably new for this lesson. The other way is in something called radians. And because this little piece right here isn't my favorite, and I don't think it's like super necessary, we're going to skip those. And I'm just going to show you guys the conversion between a radian and a degree. So the way that I'm going to do this is I'm going to show you right here about the circumference of a circle. So the circumference of a circle is 2 pi r, okay? And so this, every time you see this pi, it usually means you're in radians, which are like, I have no idea. We usually just use 3.1 for that. But also, I need to let you know that we are on something called the unit circle. And so if we're on the unit circle, unit implies 1. So that's actually where r equals 1. So if we combine these two things, the unit circle and the ratio for circumference. So keep in mind circumference is the trip around the circle. So that's the rim, which we know is 360 degrees. But what is it in this new measurement called radians? Well, if the radius is 1 and we substitute that in, we get c equals 2 pi times 1, which means the circumference in radians is the same thing as just 2 pi, because 2 pi times 1 is 2 pi. So that lets us know that 360 and 2 pi are equivalent. And if you read through this, you can see right here that's there. So right now, what I want you guys to do is pause your video and work in your group to figure out these two ratios. So again, it's just a ratio. It's just a pattern that you have to pick up. So on the left here is what happens in degrees, and on the right here is what happens in radians. So what you'll see is down at the bottom, we know that 360 equals 2 pi, okay? So a trick you could use is, okay, well, if 360 is 2 pi, and then I divide this one by 2 and divide this one by 2, what would that be? Well, 2 pi divided by 2 is just pi, which is right here, right? And what's 360 divided by 2? 360 divided by 2 is 180 degrees, because if you cut the circle in half, you'll be at 180 degrees. Okay, well, let's keep using that pattern. So what if I divide pi by 2? right? Can I reduce pi over 2? Nope. But if I'm going to be consistent, I'm also going to divide by 180 by 2. What's 180 divided by 2? Oh, that's 90 degrees. So 90 is the same thing as this guy right here, which is just pi over 2. So a good idea is always to think of pi, just plain old pi, is 180, and then use that to fill this out. So if you did right here where there's a pi, but then it says divided by 4, what that is saying is 180 divided by 4, which is actually 45 degrees, right? And then you can keep going. What's 180 divided by 3? Oh, that's 60 degrees. So go ahead and take some time in your group to see if you can figure out the rest of these ratios. I'm going to give you about 5 minutes, and I'm just going to kind of sit here and put in a 5-minute a blank space for you, just because it's really important. Why would I want you to do this? Why would any math teacher want you to do this? Because if you pick up the pattern on your own and you help your brain out, it's so much easier for you in the future. Now, I could fill all these in real quick, but if you're not actually trying to see the connection, it's going to make life a lot harder than for you. So that's why we do it this way. So go ahead and work in your groups and try and figure out what the degree measure is, which is pretty easy because you're used to working with degrees, and what the compatible or equivalent radian measure is. Okay, so this might have been tough for you to fill this out, but you can check your answers right here to see if you got them right or not. And then I'm going to show you another technique for this on the back side. So if you didn't get these, or if you're just copying instead of learning the pattern, just hit pause because I'm flipping over. Okay, so here's the back side here. I'm going to erase all this stuff I already wrote because it kind of confuses everyone. And so we're just going to go ahead and dive right in. So we already know that if we do this, it's 0, 360. And we learned that if you take one trip around the circle, and if we're on the unit circle, that the circumference is 1, or the radius is 1. So this is 2 pi, so this is 2 pi. Okay? So now we're going to take a half. So right here is 2 pi. If I only go halfway, what's half of 2 pi? That is going to be just pi. So right here is pi. Now, students have the hardest time with this because all along in math, if I asked you something like this, if I said, hey, tell me what this describes, what fraction, you would say that's 1, and then you would say that's 2/4 because you don't have the other part of this. But in radians, 1 radian is a semicircle, so it's like this, okay? So this thing up here in radians would be 1 semicircle, 2 semicircles, 3 semicircles, okay? So just to be clear, you need to be very aware that this right here is pi, or 1 pi. So you're dealing with semicircles now, not whole circles. So be very aware of that. Okay, so this is where one semicircle is. If this is where one semicircle is, right here, all the way from here to here, then what would just be from here to here? That would be half of a semicircle. So this guy up here is going to be the semicircle, which is just called pi, right? So that, but cut in half. So this is pi over 2, which we already saw was 90 degrees from before. Okay, so let's keep using that knowledge. I'm going to show you a cool trick right now. From here to here gave us 1 pi over 2. So 1 pi over 2, the 1 is invisible math, but you know it's there, okay? So if that's 1 pi over 2 and I go the same distance over here, this is 2 pi over 2. But that can reduce, and that just gives me pi, okay? And then now if I keep on going the same distance, again, just being clear, this was 1 pi over 2, this was 2 pi over 2, so now this down here is going to be 3 pi over 2, and if I keep going, that's going to be 4 pi over 2. So if we reduce 4 pi over 2, that gives us 2 pi, okay? I'm going to erase all that real quick and fill it in better. Okay, so we saw that this guy down here is 3 pi over 2, and then this one is 4 pi over 2, which just simplifies to 2 pi. Okay, so that gave us all of our quadrantal angles. These ones that end up on a quadrant are called quadrantals. That's a vocab word, but we don't do vocab tests, so that's just an FYI. Okay, so we're at pi over 2 right here. So what happens if this is pi over 2, but I want to know what's happening right here? So I'm cutting 1/2 in half. So 1/2 divided by 2, because I'm cutting it in half, is 1/2 times copy or keep change flip, so that's actually going to be 1/4, and I'm going to erase all that. That's all the math, but I don't need that. So this is going to actually be pi over 4. Okay, so watch these fractions, because fractions are awesome. This is 1 pi over 4. Okay, you see that right here. This right here, equidistant, because that's how fractions work, is that they're equal, is actually going to be 2 pi over 4. But hopefully you notice that that reduces to pi over 4. Next, we're going to cut it in half again. So we're going to get to this guy right here. This was 1 pi over 4 to here. This is 2 pi over 4. So this guy is 3 pi over 4. And if I keep going all the way to here, that is going to be 4 pi over 4, which just reduces to pi. And then we can keep going around the circle. It's so cool. So we're going, again, we're trying to bisect. So I'm not stopping at 210 or 240 because those aren't in the middle. So if this was 4 pi over 4, then this is going to be 5 pi over 4. And then we're going to keep that pattern, same quarter slice. So this is 6 pi over 4, which reduces, and that's going to be 7 pi over 4. And then we get to 8 pi over 4, which is 2 pi. So now I'm going to erase all that, just so I can clean this up to do the next thing. I get lucky enough to be able to erase all this stuff so that I can just fill it out. Okay, so again, this was pi over 4, 2 pi over 2, which is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Okay, math is awesome that way. It's all based upon ratios, so all this works out. Okay, so what we just did were our 45-degree angles and our quadrantals. So I'll just put these on here just in case you missed them the first go round. And this one is 270 degrees. All right, so now we're going to work with our 30, 60, 90. Obviously, you guys have seen special triangles because I know you did them in math too, regardless if you were in college prep or honors. So we have our 45, 45, 90 triangles and our 30, 60, 90 triangles. So let's look at what our 30, 60, 90 would be in radians. So keep in mind, if I go one whole trip around the circle, that's pi. So if I go halfway, it's pi over 2. But what if I strategically pick these 30-degree angles? So I'm ignoring those 45. So right now, all of these, I'm just adding 30 degrees to get these angles right here. What would that look like? Okay, well, let's break it down using our knowledge of ratios. This right here is pi, and I have 1, 2, 3, 4, 5, 6 pieces. So this is really 6 out of 6, which reduces to pi. So if that's 6 out of 6, that means 6 equivalent pieces, and this one is 1 out of 6. That's going to be 1 pi over 6, or just pi over 6. This one is going to be 2 pi over 6, which is going to reduce to pi over 3. This one is going to be 3 pi over 6, which reduces to pi over 2. This one's going to be 4 pi over 6, which reduces to 2 pi over 3. This one is 5 pi over 6, which doesn't reduce. And this one is 6 pi over 6, which reduces to just pi. Then I keep going. This is 7 pi over 6. That one's 8 pi over 6, which is 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. 11 pi over 6, which doesn't reduce. And then we're back with 12. So 7, 8, 9, 10, 11, 12. So again, remember it's semicircle. So the semicircle equals 1, not the entire circle. And 12 divided by 6 is 2 pi. Okay, so you will get so comfortable with those measurements, and I will help you with that, but you will have to know those. So if it's tricky, in the beginning, we do have a conversion, and the conversion is right here. It says if you want to go from degrees to radians, you just multiply by pi over 180. And then some students in the past have said, Miss Wolkin, but isn't it 2 pi divided by 360 is the ratio? Yes, it is, but no mathematician is ever going to leave this like this because 2 goes into 2 once and 2 goes into 360, 180. So this is when you're going to degrees to radians. You want to make sure the pi is in the numerator. When you're going the other way, radians to degrees, because you're going to end up with degrees, you want to have 180 in the numerator. Okay? All right, so question 2 says, convert each measure from degrees to radians or radians to degrees. So we are given 20 degrees, so we are going to convert it to radians. So the way we're going to do this is we're going to times it by pi over 180 degrees. So if you've taken chemistry, you know that your units need to cancel, and so that's by degrees needs to be in the bottom. So I have 20, the degrees are going to cancel, and then I'm going to get 20 pi over 180. And then I'm just going to simplify from there. So what I'm going to do is 20 goes into 20 once, and 20 goes into 180 9 times. So this ends up equaling 1 times pi is pi, and then over 9. So 20 degrees in radians is pi over 9. Okay, negative 540 degrees. So negative 540 degrees, we're going to go to radians. So we're going to times this by pi over 180. Again, we know we want the 80 and the degrees in the denominator, so that cancels. So we end up with negative 540 pi over 180. And then obviously you guys probably know at this point that zeros cancel each other out. But then how many times does 9 go into 54? So if I divide by 9, I get negative 54 divided by 9 is negative 6, and 18 divided by 9 is 2. And then that's when I see that I can still continue to reduce. So 2 goes into 2 once, and 2 goes into negative 6 negative 3 times. So my answer is going to be negative 3 pi. So these are just conversions, but it's so much easier if you just know those. Okay, 4 pi over 3. So now we're going to be going to radians. So if we're going to radians, that means we want the pi in the denominator so that it'll cancel with the numerator. So those will cancel right there. And then I'm just going to try and do some reducing right here. 3 goes into 3 once, and 3 goes into 180 60 times. And I am going to be left with the degree symbol because that's in the numerator. So I'm going to do 4 times 60 is 240 degrees, and everything in the denominator is 1, so that's good. Alrighty, negative 10 pi over 3, so I know it's going to be negative, and I'm going again to multiply with the pi in the denominator. So then the pi's cancel out, and then I'm just going to reduce 1. 3 goes into 3 once, and 3 goes into 180 60 times. And then I have negative 10 times 60 degrees equals negative 600 degrees. Okay, last little bit is about coterminal angles. Coterminal angles, our vocab for that is that coterminal angles end up at the same spot, so they start and end at same location. The start one is a little tricky because all angles start at the same spot when you're on the circle, so that's not really a big deal, but that confuses kids. But they end at the same location means that they might take extra loops around the circle, or one might be positive and one might be negative. So to find coterminal angles, you are going to add or subtract the full circle. So if you are in degrees, you're either going to add or subtract 360, and if you're in radians, you're going to add or subtract 2 pi. Okay? So let's go ahead and take a look at this. It says draw the angle in standard position and find the nearest 2 positive and the nearest 2 negative coterminal angles. So let's start with the drawing. 230 degrees So we know this is 90, 180, 270. So 230 degrees this is quadrant 1, quadrant 2, quadrant 3. So 230 degrees in quadrant 3. And is it closer to 270 or closer to 180? So it's 50 away from 180 just by doing subtraction, and it's 40 away from 270. So you don't want it to be exactly in the middle, but it's about right there. So again, this is a positive angle, so we went up and around. And then the next part of this is to find the nearest to positive and the nearest to negative. So there's an infinite number of coterminal angles. So let me draw this line right here. And I'm going to put 230 right here. So because we're in degrees, we're going to add 360 and to get to our next coterminal angle, which will be 590 degrees. And then I'm going to add another 360. Again, I'm doing this in degrees because it was given to me in degrees. And then I'm going to get 950 degrees. So my nearest two positive coterminal angles are these guys right here. And just so that you guys see this real quick, I am going to graph those on the unit circle because it might have been a while since you've seen something like that. So if I was to ask to graph 590, I'm going to start here because I always start at 0. And I go 9, 18, 27, 36, 45, 54. So you're like, what the heck is she counting by nines? I'm just eliminating the 0 on each of those. And then I'm trying to go to 590. If I'm right here at 540 degrees and I go 50 more, I'm going to end up. So that's what coterminal means. Both of these angles will be looking exactly like that, except for we're going to have like an extra trip around the circle. It's an extra spin. And then to go the negative way, the two most negative coterminal, I'm going to subtract 360 and hope it ends up in a negative because it doesn't always. So that one is going to be negative 130 degrees, which is negative, and then I'm going to subtract another 360, and that's going to give me negative 490 degrees. Ooh. Don't like the color coding on that. So my here are my -2 right there. Okay. All right. Co-terminal, like co-captains. You're at the same spot, start and end through thick and thin. Okay. So let's go ahead and move on to the next one. All right, so first thing we got to do is graph negative 740 degrees. These kinds of things are a little bit tricky for students. So again, your best friend is going to be able to know your times tables. So this is -9, -18, -27, -36, -45, -54, -63, -72, -81. And I counted by nines, but we know all of these have a 0 on them. Okay. Why did I stop right here? It's because my angle of -740 degrees is in between -720 and -810. So what happened is I went -9, 18, 27, 36, -45, -54. Ooh, whoops, I like that circle I drew. And it's going to come all the way back till I get in between here. So is 740 closer to -720 or negative 810. So it's going to be closer to negative 720. It's only 20 degrees away. So that's where that angle is right there. And then I'm going to set up my little chart here so that I can make sure that I answer the question appropriately. So the number I'm given is negative 740 degrees. And it says the nearest two angles that are negative and positive. So the first thing I'm going to do is I'm going to add 360. And when I add 360 to negative 740, I end up with negative 380, which is still a negative angle, okay? And then I'm going to add another 360, which gives me negative 20, still a negative angle. But we need two positive and two negative, so I better add another 360, which gives me 340. And then I'm going to add another 360, which is going to give me 700. So right now, I know my positive and negative angle that are nearest are these two. And I also know that this guy right here is one of the closest negative angles, but guess what? I can actually subtract 360 from here to get an angle that's closer than negative 20. So if I subtract 360, I get negative 1100. Negative 1100 and 380 are both closer to 740 than negative 20. So you have to pay attention to the wording. All right. Okay, next one says to go ahead and graph in radians 16 pi over 15. So I think this might be tough for some of you. So what I want you to do is convert this to a mixed number. So this is 1 and 1/15 of pi. And then remember, the 1 represents a semicircle, not a whole circle. So what that says is that you're going to do, this is pi, this is 0. You're going to go to this, and I always like my students to change this to whatever the fraction denominator is. So you're going to go to 1, and then you have another 15th. That means that this whole piece down here is cut into 15 equal pieces, and because you only have a 1, you're only going to the first one. So it's a sliver, okay? So it's a little tiny sliver. So let's say it's right there, okay? So now what we're going to do is the math to find these coterminal angles, okay? So here's our line, and we have that we are at 16 pi over 15, and because we're in radians, we're going to add 2 pi and subtract 2 pi and hope we get a positive and negative to start with. Otherwise, we're going to have to do more math. So 16 pi over 15 plus 2 pi. So plus 2 pi is 2 pi over 1. Do our fraction math. We're combining like terms, so these have to have common denominators. So really what we're doing is we're adding 30 pi over, whoops, I only wrote 3. 30 pi over 15 to 16 pi over 15, which ends up giving us 16 plus 30 is 46 pi over 15, okay? Which is positive. And then let's go ahead and add another 2 pi to that. And if we add another 2 pi to that, because the denominator is 15, we're just going to be adding another 30 pi over 15, which is going to give us what? 76 pi over 15. So there's our two positives. And then to get our negatives, we're going to subtract 2 pi, which means we're going to do 16 pi over 15, and then we're going to subtract 30 pi over 15 because that's 2 pi with common denominators, and that gives us negative 14 pi over 15. And then we're going to take negative 14 pi over 15, and we're going to subtract 30 pi over 15, and that is going to give us negative 44 pi over 15. So those are our two negatives. So it's nothing like super intense or like difficult. You just have to be able to subtract fractions. So we've already practiced that, but it's always a recall issue. So last one, negative 18 pi over 7. So 7 goes into 18 2 times with 4 left over. So when I graph this, this is 0 and this is negative pi. And it's negative because this is negative, so we're going to go down. So this is negative 2 pi. And now we have 4 out of 7. So we're cutting this into 7 equal pieces and approximating 4. So the way I like to do this is I look at this part of the fraction right here. Is that bigger than a half or less than a half? So 4 out of 7 is bigger, which lets me know that this should go beyond the halfway mark. So there's negative 18 pi over 7. And at this point, it's the same thing as before, except for we probably are going to have to do some more positive work. So right here is negative 18 pi over 7. And then in order to find a positive one, we're going to add 2 pi. And 2 pi is going to be 14 pi over 7 when we have the common denominator, which is actually going to still give me negative 4 pi over 7. So that is actually not a positive one yet. It's a negative one, but that's okay because we have to do the two closest. So now I'm going to add 2 pi to that, which means I'm going to add 14 pi over 7, which is going to give me 10 pi over 7. So the next one is 10 pi over 7. Yay, it's a positive one, but I'm supposed to find 2 of each. So I'm going to add 2 pi to that guy, which means I'm going to be adding 14 pi over 7. So that's going to be, when I add it to that, 24 pi over 7. So I found 2 positive, 1 negative. To find the other negative, I'm just going to go ahead and subtract 2 pi, which means I'm subtracting 14 pi over 7, which means that's going to be negative 32 pi over 7. And that's what coterminal angles are. The end.